How are moraines related to glacial retreat? Have you ever wondered how glaciers leave behind clues about their journey? One of the most fascinating features they create is called a moraine. So, how are moraines connected to glacial retreat? Let's break it down. Moraines are essentially piles of rock, sediment, and debris that glaciers carry along as they move. When a glacier retreats, meaning it melts faster than it advances, these moraines become important markers of change. They show us where the glacier once was and how much it has shrunk over time. There are different types of moraines, but the most relevant to glacial retreat are terminal moraines and recessional moraines. Terminal moraines form at the furthest point a glacier has advanced. When the glacier melts and pulls back, it leaves behind a ridge of debris. This ridge marks the maximum extent of the ice. On the other hand, recessional moraines are formed during temporary pauses in the glacier's retreat. These create a series of ridges that trace the glacier's stepwise withdrawal over time. So, when we look at these moraines, we can see the history of the glacier's movement. The connection between moraines and glacial retreat is clear. They are like footprints left behind by glaciers as they shrink. Scientists study the location and makeup of these moraines to understand how far glaciers once reached and how they are retreating now. This is especially important in polar regions, where large ice sheets dominate the environment. In polar areas, moraines provide tangible evidence of changing ice margins. They help scientists track the effects of climate change on these massive ice formations. Some moraines, known as push moraines, form when a glacier briefly advances or stabilizes during an overall retreat phase. They record short-term changes in glacier behavior, like seasonal advances during colder periods. Understanding moraines is vital for grasping the dynamics of ice sheets and glaciers in response to climate variations. As glaciers in polar regions retreat due to warming temperatures, moraines document these changes. They also shape new landforms and affect drainage patterns once the ice melts away. In essence, moraines are directly related to glacial retreat. They mark the former edges of glaciers and record the history of ice loss. By studying them, scientists can monitor glacier changes over time, especially in polar environments where ice retreat has significant impacts on sea levels and ecosystems. So next time you hear about moraines, remember they are more than just piles of debris. They are key indicators of our planet's changing climate.